The semiconductor ecosystem has a truly global footprint. Chip-related operations and facilities span virtually every continent and type of climate. It is the shared responsibility of all chip companies to protect people and our planet. Chip manufacturers are subject to stringent environmental regulations and share a long history of environmental stewardship. As technology evolved and the use of critical chemistries increased, both industry and governmental entities began comprehending the need for safer alternatives, optimized processes to reduce consumption, and expanded controls.
Environmental initiatives that are important to the semiconductor industry include, and probably start with, climate initiatives to reduce our greenhouse gas emissions. This is something that we've done as an industry for multiple decades. We're really a leader in this area. And because of that, our emissions are dramatically lower today than they would have been had we not taken these actions for multiple decades.
Manufacturers have a deep understanding of the environmental, health, and safety impacts to employees and surrounding communities. This understanding has led to the continuous implementation of best practices and smart control technologies. Environmental health and safety, or EHS programs, are intrinsic to the industry's DNA. Today, across the ecosystem, companies are committed to continually evaluating and mitigating risk to maximize EHS protections.
So we use a management system approach, which a key part of that management system approach are conducting risk assessments. And those risk assessments are conducted when we're identifying a new technology, a new chemical, a new tool or piece of equipment that's coming into the factory. And we also use those same risk assessments for work that's occurring on site. Facilities work, they're going to do some work within the subfab. They need to conduct a risk assessment prior to that work. The benefit of this approach is that it helps prevent injuries and incidents from occurring on site.
This shared EHS commitment is embodied in facility infrastructure, embraced by employees, and reflected in partnerships with local municipalities. In the communities where chip manufacturing facilities are located, health and safety teams work in close concert with regional utilities and leaders to help preserve the integrity of resources and protect citizens. Control of chemical use extends into the comprehensive treatment of wastewater, waste, and air emissions. Fabs use large volumes of ultra-pure water and aqueous-based formulations throughout the manufacturing process to clean, etch, and planarize wafers. While some chemicals are collected for reuse or reclaim, other chemical residues are treated. Semiconductor fabs typically have a network of wastewater drain systems that convey processed wastewater through a series of pre-treatment steps. Waste and wastewater management strategies vary according to the fab design, chemistries used in the process, and applicability of local, regional, and national pre-treatment requirements. Understanding that water is a precious resource, fabs work aggressively to minimize water consumption and maximize its reclaim and recycle.
This is important to me because I come from a wastewater background. I've always been interested in everything that goes down the drain and how it impacts the environment down the line. So working here, it's interesting to know everything that we put into this process and how it comes out and how we can mitigate any sort of potential issues to the environment, and that's important to me.
Semiconductor manufacturing requires use of a wide range of metals, acids, alkalis, and organic and inorganic chemicals that may have hazardous properties. Waste management efforts focus not only on safely transporting and disposing of these materials, but also on recycling and reuse as part of promoting a circular economy. An example result of this effort is that the industry contributes less than 0.05% of the total chemical release risk identified through U.S. EPA's Toxic Release Inventory. The industry also strives to minimize air emissions and their impacts through the implementation of chemical replacement, use optimization and exhaust collection, segregation, and specialized air abatement systems. To that end, 30 years ago, the semiconductor industry committed to reduce use and emissions of long-lived greenhouse gases. As an example, today, semiconductor manufacturing in the United States contributes less than 0.1% of total U.S. greenhouse gas emissions.
I think that the industry takes the environmental impact very seriously, and over the last several years, there's been a lot of effort to really take a close look at ways to improve sustainability. The one example which is very, very active is in finding replacement chemistries to reduce the carbon footprint of processing. This is an industry-wide problem, And I feel really confident that it will come up with some viable solutions that are acceptable from a process standpoint, from a cost standpoint, ultimately leading to a higher sustainability and lower impact to the environment.
To help identify key environmental priorities, the industry collaborated on the creation of the Microelectronics and Advanced Packaging Technologies Roadmap. It is the first technology roadmap that focuses on sustainability as a key factor for planning future innovations and is framed around the 3 pillars of people, planet, and prosperity. Guided by the goals of this roadmap, the industry will continue its decades-long stewardship, minimizing waste and conserving resources as part of its deep and unwavering commitment to protecting the planet we share. Next, we'll glimpse into the future of the semiconductor industry and look at the challenges and opportunities along the road ahead.